Okay, another interesting problem. This one is dealing with electrostatics, again, coming from a homework problem that we have in the live training program. And I've worked through this in a lot of detail. I'm not gonna revisit, step by step. Let's look at the question directly. Student is saying that, let me ask you, in this question, let's say we use negative charges instead of positive charges. That will completely change the direction of the force, right? Again, the student is asking me whether that would be the case. I think that you can very easily do that, and we'll do it very quickly. Meaning that even though the force exerted from -2 charges on the test charge, the arrow will converge into the -2 charges. Is that right? So the student is making an assumption, suggesting something and then asking me for feedback. I'm trying to visualize different scenarios with questions 4, 5, and 6 of the homework. Thanks in advance. So let's take a look at what the scenario is. We have actually a point charge plus 1 nanocoulomb located at the origin of the given charge arrangement. So this is kind of messy. I don't know if you guys can see it properly. If you have access to the homework problem, you'll be able to. And in the lecture, I've basically worked through it in a lot of detail, but let me just quickly recreate it. And then what we have over here is that on the 4 corners at equal distances, we have 2 Coulomb charges, right? So let us assume that this is a square and we have plus 2 Coulomb charges, right? Again, if you visualize it and if you have a little bit of a sense in terms of spatial arrangement, you'll see that the net force in this very symmetric arrangement and equal value of charges is going to be 0, because all of these force lines are going to cancel each other out, right? Now, what the student is asking is that, okay, let us assume that instead of the plus 2 Coulomb, so when we have a positive charge, we know that the field lines actually radiate, correct? So if I have a positive charge, we know that the field lines actually radiate, correct? And conversely, if we have a negative charge, then they converge. Okay. Now he's suggesting entertaining a scenario where instead of plus, we have a minus, plus we have a minus, plus we have a minus, plus we have a minus. So what does this mean? So at the moment, think about the positive 2C's that are part of the original problem statement. They are shooting missiles, right? In this direction. And the net effect is that they're equal missiles being fired from the 4 symmetric directions, 4 symmetric corners. And the net impact is that this plus 1 nanocoulomb is sort of stuck because it's being forced in from all directions and it's sort of still in between. Now, the other way is that if you think of it as -2 coulombs, and these are the exercises, guys, that you have to do mentally, right? And if it's minus, then this direction is going to change. It's going to be pulled, right? So essentially, just like a fishing hook, right? We are trying to pull the plus 1 nanocoulomb in this direction, in this direction, in this direction, and in this direction. What will be the net effect? The student is correct. The net effect would be that it will still be stuck, right? Because there's an equal and opposite pull from all different directions. Okay. And please work through this problem in detail. It's a very interesting problem. I think in one of the next questions, so this is 5, I think in 6, I end up removing one of the charges, if I'm not mistaken. And then you have only 3 charges. And then the dynamics are going to change very drastically, right? So make sure you have a good handle on the unit vectors. The math is kind of tricky. We've discussed it in detail in the on-demand course. We've discussed it in detail in the homework assignments. And it is very important that you are comfortable. So one of the ways that I solved this problem was by resolving these vectors in their x and y components, right? When you remove one of the corner charges, then the x and y components will no longer completely cancel each other out. And the net effect would be that this guy was going to move in this direction, right? Here? Any questions? Is this an example of electrodynamics or electrostatics? Well, it's right here. Electrostatics, as you guys know, works with stationary charges, right? Electrodynamics is when we have a rate of change, dt, coming into play. And that's essentially what Maxwell's equations deal with. Okay? So for further practice, I strongly recommend you guys to work through the on-demand content, the quizzes, the mini exams. with this attention to detail, right? With the focus and making an extra effort in terms of sketching and visualizing, because that can make a lot of difference on the exam. So that's my response, correct? When you are using negative charges instead of positive charges, the direction of force changes. The field lines are converging into the negative charges, but even in that case, also the net force exerting on the test charge will be equal to 0 because of equal forces in opposite direction. Note that X and Y component direction is also changing because previously the missiles were being fired. Now it's basically being pulled. So the direction of the force has changed, but the net effect is still the same. If you're new to this channel, please consider subscribing. On a weekly basis, I'm creating content for FE electrical and PE power exam preparation. I also discuss topics related to electrical engineering with a focus on power systems engineering. If you'd like to learn more about my FE electrical and PE power exam preparation programs, please visit my website, StudyforFE.com.